Now you can hear me. Okay, I'm sorry. I don't know. That happens sometimes recently. Um, it started acting up. I don't know if it's changes to Windows or whatever because I didn't power it down, but it stopped working after I think it stops working after hibernate or sleep when I put my PC in sleep. But I didn't update my PC for 90 days, 100 days, something around about that. My system uptime is 100 days or something. We checked it on Tuesday. Okay, so I say hello again to Sonic, Ameboid, Tech, the Shipu, Dutch, Johnny, and Ameboid second time. Okay. Who needs security updates? Yeah, I'm not reachable from outside. Not opening any emails. No, I'm not reading my emails. Okay, peeps. So, I was today as a repair stream. I can show you. I was talking about my old Ford Focus that I'm driving now for almost 20 years. And it started like I had problems with my instrument cluster, and I show you what the current state of my instrument cluster is here. It's just stuck in the boot loop. Do you see that? Okay, so musical instrument cluster. So yeah, I searched online for what could be the reason because it's party mode. Apparently, here's the PCB. I took it apart. I recorded it also, so I might do. I scratched. Of course I scratched a little bit while taking it apart, but that doesn't matter. It's an old car. I don't really mind. You clean that up. So I took it apart. Here are the indicators. So you have to pull it apart a little bit. So this is how it looks like, and when they are resting, I don't know. We can turn it on and recalibrate everything. I hope. I marked it where the last position was of the instrument. However, typical error of, because I was still driving with this car, I couldn't see anything, and then after I don't know 10 minutes or something, it was okay again for a few minutes, and then the next time it stopped working again. And the usual problem with those is that you get cold solder joints because like this is the main connector, and from the vibrations over time, if you drive around, the connections of the through hole connector break. And that's the thing. No, I don't think that will be legal to do so. I could though. There are no. I think the LEDs are colorless, and then you have like the shield, the front, the panel as a colored. No, actually, there's not colored. It's colorless. I can show you. Maybe you can see. Wait, this way around. You won't be able to see that. Yeah, it can't focus. It will find my face. Anyways. Yeah, I took it apart and I want to rework that PCB. Rework the PCB and in the end I hope it works again. If not, I can just buy a replacement for 50 bucks from a used car. The only issue is that I think I would need like to swap the flash or something. I think this could be the flash for to have my kilometer count displayed correctly there. All right, I was just sleeping, taking a nap, and you can decide what I drink today. Monster Energy Zero, which is half a liter, or Booster Absolute Zero, which is 330 milliliters. Because I was like super tired. I have also had both at the same time, mixing them. Okay, I think I will start with the booster because it's quite crash. Yeah, let's see. Booster smell. Both have the black color. Anyways, I took a look at the board already, and we will not ramble for too long. We will just continue. Oh, yeah. A teddy drink. Look what I have. Guess what MCU that is. Guess the MCU. No, it's not an RP. It's also not custom ASIC. $80 mega. Johnny wins the prize. I showed you the label. You just needed to read it. It's a CH32H417. There are only like 300 in existence of those right now. It's just released. It's a dual core with vector multiplication, so it's like support for AI calculations. Dual core. One is I think 450 megahertz, and the other one is slower. So it's the latest and greatest shit from WCH. And I also got, okay, here's the dev board. What is reconnected chat? The chat is working. Oh, this one doesn't work. Oh, wait a second. Yeah, you're right. This is the on-screen chat. What's going on there? Here we go. Okay. It's back there. All right. So I got a dev board for this MCU here. So I got 3 MCUs from all 300 of existence. It's the first version of this MCU. Since it's public, I can also talk about it. We can test it. It has a USB 3. Yes! And it has Ethernet, as you can see. I think the maximum speed, I have some details on that one. Maximum speed is 800 megabyte per second or something. And I got a different MCU as well, which could be an alternative for the next cluster that I make. And this one is, I just need to, because I don't disclose here. Need to cover that here. That's a teaser. Also QFN 20 pin. Nice little MCU. Nice features. It's quite similar to the 570 that we used for. It's Bluetooth. Does it run Python? Probably can. Oh no, you need like some RAM, huh? What's the minimal RAM for running Python? Hey TMK. 32 kilobytes. Okay, then it won't. Sorry, it won't. It is a small. It's just 1 RMB MCU, so it's another 13-cent MCU, quite similar to the 570. But I won't reveal any further details because that's not disclosed yet. I might be one like to announce it or something. At least I want to try to use it for one of my projects. But now we will debug and rework my wait. Hey Dan helped me today with the schematic for the circuit that we want to repair. Wait, let me. Where's the microscope? Let me turn on the microscope camera. Here we go. So Dan helped me getting the circuit. I think this is it. There we go. We can take a look at the connections. Oh yes. So we have the connector, the pin, anti-lock brake system, ABS. Okay. BLK. What's BLK in? Yeah, but I read somewhere that they are interchangeable, like the instrument panel is interchangeable. And what I just need to find out for now is which connection would be power. So instrument cluster, okay, that's just low brake, low oil pressure. Where's the power input? Power flows from top to bottom. Oh, so this is... what? 7, 3, and 3? And there... Oh, this is fuse. Okay, I see. This is the fuse junction box. Okay. So these are the pins 7, 3, and 3. So we have 10, 16, 14, okay. 14, 16, 14, 16, and 10. Okay, let's take a look. I need to zoom in. Zoom in here and go to microscope and we will... Okay, here we go. Let's turn around, zoom out. Whoop. Here's the connector. And this is the other side. Let me fix the focus here. And we can zoom in. Wait, I need to have the same focus as you have. We can zoom in and there is an SMD cap on your table. No. It didn't come off. I have like always stuff on my but I will show you what the issue is, why I asked you then to help me with the what the fuck is my something to point. This is not a good pointer. I need something to okay, I will just use the tweezers here. Okay, so we have you can see there are thicker wires. This is ground. We can see it's connected to the ground panel. Here you can see already. Let me zoom in even further. Do this. You can see, I think this must be the power. So it's probably not the same configuration because we have a thicker trace and there is some stains. So I'm not sure if it has, in some places I see it has some conformal coating, but then I also see like this strange corrosion on top of it. So I might need to scrape it off and put some tin on top of it, but it's like really weird. Really weird. Okay, that might be power. So last pin is power. This is. Oh yeah, I can do that. Checking continuity. Oh, that's too far zoomed in. Anyways, we have quite a few. I don't know if these are few. No, these are caps. Those like caps. But separate tenting. Okay. Then we have some more thick wires. I don't know. There's also a cap here. This should be some sort of power. Then this is like, I don't know, this is just ink. But I will show you the places that I don't like. So there are no cold solder joints or whatever, so no physical damage on the connector. I checked, you can see like that's like pristine. So there is no physical damage on here. At least I don't see anything. So I wouldn't like to touch that up because that's as nice as it gets, the soldering here. But what I found is, first of all, like it has to do with the power. So this one here, I don't know what kind of stain this is. Probably some sort of, look at this here. What's happening here? Okay, this is like on the coating, but where's this coming from? Or here, there's like gunk collected on top of it. It looks like there could be maybe moisture and it just, I don't know, charged. This is, by the way, the chip, if you want to find that. What I will show you the other side. The other side is quite interesting. This is just, we getting started. I wasn't able to find this chip. And can anyone find the datasheet for BN304? Because that should be that should be a voltage regulator, I assume, because we have a bigger cap here. This might be like coming in power, and this might be the output power. It's also going to a 100-volt cap. The caps seem all right. I don't see like any like physical damage on those. So there is bigger capacity on here, and that might be like power. Here are more caps. I don't know what. Maybe there are different power levels, but I didn't find for BN304, I didn't find the data sheet. Wasn't able to. I don't know why. Then we have, oh wait, I need to crank up the heating here. I'm really almost freezing. What's going on? Okay. Okay, let's take a look at the other side. So it doesn't look that bad, I'd assume. But then I go to the other side, and this is the side with the connector, so it's more exposed to the air or humidity or whatever, and then you see stuff like that. So why? Where is this coming from here? That's really weird. I mean, this is like on the conformal coating or solder mask. I don't know. It's really strange, and it. Tendrils, like literally tin creeping. It could be. Because you can see like there is a metallic effect on this one here. It looks strange. It also looks like we can scrape it off. Look at this. Look at this. Here also it's creeping underneath the coating. It feels like there is a conformal coating on top of that, so they're like tinted or whatever. We have some test points. Test points are okay. So this tin isn't affected whatsoever. It's only these places. And look at this. That looks like really worrying here. I would assume that these points here could be somehow shorted. And what I don't know is should there be a connection? We can scrape it off and see if there is like remaining copper, because when I repair this, I need to know what's happening there. Look at this here. What the fuck? What is that? Never saw something like this. Residues from production? Okay. That's a guess, but I will show you. Where was the other place that I saw? Like here. Start of Last of Us, yeah. Okay, we saw that one. One issue could be that I have some vias underneath the connector, which could be the power vias. And yeah, look at that. Oh yeah, that we scraped that already. Or is it? Like I assume that could be one of the issues. And here is more. You know, you saw that. Yeah, I need to. Yeah, that's what I want to try to pull it like off. The pins are soldered nicely, so. But yeah, it won't be super easy. What I want to find out which one is the power pin. So I don't think the schematic will help us, because it looked like the power pins are on the outer side here, and according to the schematic, it didn't look like. Wait, oh, power could actually be 14 and 16, and we have, that's 4, 8, 12, 14 and 16. So this could be 16 and this could be 14. No, this is ground. 14 is this one here. Oh, yeah. Actually, that could be the two power pins, 14 and 16. 14, 16. Okay, that makes sense. We could give it some 12 volts and see what happens. So that's a thing. What is the other one that we get? 10. Okay, we can also check power pin 10. That would be 14, 13, 12, 10. Yeah, that doesn't look like it's a power pin. This looks like a power pin. 1. Look at that. There's a solar blob. Oh, there's even more. That's strange. Ah, solar balls here. D-shaped. Oh, top pin D-shaped, you say? Number 1. Oh, this one, yeah, 1. Okay, so then it would be like ground will be pin 2 and power pin 3. Weird. Okay, yeah, then that doesn't look, but you're right, like D-shaped pin. That could be still, no, 14, yeah, 14 makes sense. If they go around, that's 15 then, I don't know. If I can find like for the regulator, the data for the regulator, the data sheet, I could connect power there and see if it turns on. But I would suggest to clean up, scrape off all the obvious issues. On the PCB, let's begin with this side and then see what we need to do here. Oh yeah, you wanted continuity test. Yeah, I don't care actually, because that could be. Okay, let me check underneath this here. Okay, that's just ink. This is all right. Yeah, that's not an issue here. There is a connection here as well. Okay, that's just ink. Yeah, these ones here. I might just put some solder on that to thin it a little bit. Oh, you sent a document on Discord? Okay. Let's just do this side first. Whatever we see here. Oh, thank you for the resub. Nice. I don't even know if this is the issue. The issue could be somewhere else, like with power. But looks like it could be. It's like the main instrument is in the boot loop, because we see like everything turning on and off all the time. This is my car. We're working on the PCB of my car, trying to repair, like remove corrosion and okay, let's start here and go through everything. We can see vias are thin plated, yeah. Here. Yeah, I hope these things are not like multi-layer, just like 2-layer boards. But it should be like, doesn't look very fancy to me. Yeah? There is some corrosion here. I might need to put some nail polish on top of it. Yeah, I don't actually see like many layers underneath, but I usually on the side of a multi-layer board you could have like a indication for that, but I didn't see anything. I don't see anything here. Wait, is this the ground pin? Yeah. No, it's not. Huh? Yes, it is. Yeah, this is a ground pin. So there was like a some kind of weird charge going on between ground and power. Carbon track. I don't know. I'm not very familiar with stuff like that. But as so far, I don't see like a super big issue. It's like not like it would be super shorted or anything. It might be some creeping power or whatever, but not like actual short or cut trace or anything. I think I saw somewhere something that looked. Yeah, I will be sure when I plug in afterwards. I will just clean up everything because I wouldn't leave like charred vias anyways. I can simply plug it in without the case and see if it's rebooting all the time again, like boot loop. I hope the vias are like plugged vias here. It looks like they're plugged. Look at that. That's plugged vias. I can do both. Bench power supply. We might want to set up, I mean, my phone should be stronger than the old one, and we had some sort of streaming there. So I could bring you along. Is this ground? No. Okay, that's a good issue. I can try to just clean it off with IPA, but Ritter Sport Factory, what? Bring that over. Do I have Q-tips here? Or swipes? But I have. Ah, B-Ware. Yeah, it looks like, I don't know, it could be like something on top that's still somewhat connected. I don't know, might be just, I mean, it was working, it could be just a collected resistance or capacitance that's built up from those strange corrosions here that makes it like reboot or restart or whatever. Where is it? Waldenbruch? I don't know where this is. Doesn't sound familiar. What's the biggest city close by? Nice Christmas tree ornaments. Here is another one. This is the side of the PCB that's not very bad. Like the other side is way worse. Sindelfingen, yeah, that's not close to me. I still don't know where Sindelfingen is, but certainly not close. Stuttgart, yeah, that's in the south. So probably a few hours drive. Not worth spending less for the chocolate though. But we can go, like close one to us is Viba. They are making like nougat stuff. It's also a factory. And then you can, at the factory, you can eat like from a fountain, nougat fountain, and so on. That's like half an hour from here. Business expense, yeah. Yen. I also don't know many cities. This one looks a little bit sketchy, but it's only like blue. It doesn't look like bad or anything. It's like, I don't want to mess around too much close to the CPU here. Yeah. Okay. Now let's move to the other side. Light stains. Yeah, I know you're complaining here about. I also need to. Sharpness. Don't have autofocus on this one, unfortunately. Doesn't look as bad. But that's just the beginning. I mean, I could just, in 1 year, I could just find out again. Or experience a catastrophic failure there. I just stop it. Here, look at this. This is underneath the coating. This is really bad, this one here. Because that looks like it's shorting to this spill. It's coming off way easier. Yeah. No, the coating is still intact. It's so strange. It's weird. It's like spilling from the center. Maybe it's like plugged vias and the internal of the via is corroding away. It's like steel or something. So the resistance, the inner resistance of the via might be actually an issue. Need to find out. What else do we have? We have plenty of issues here. Again, look at that. Shit. Yes, I can. I don't have an ultrasonic cleaner that's big enough for this board. And I also don't want to submerge the indicators because I don't know how the motors react to that. Or solenoids. Okay, this one. Okay. I just need to get rid of anything here. That could be connecting this ground here. It's strange. It's like the connection between like spill to ground, to this ground via. And where is this one going? I don't know. It's also spilling here. So this coating on the vias isn't as good as it needs to be. Okay, let me check if I can see. These here look all fine. Here is some more trash. It doesn't look like it's an actual short because the solder mask is still functional. It's like it's spilling on top of it, charged by the potential between the via where it's coming from and the ground plane surrounding it. It's weird. Continuity of the vias, yeah. I might just at some point it wouldn't be worth, I just get a new instrument board. If I want to, I can swap the flash. If it's flash, I don't know. We can check if it's flash. Wondering what kind of information is stored there. Yeah, I think that's the copper via corroding, yeah. So, and what's the suggestion to fix it from EI? Then, by the way, your TTS voice has a heavy French accent. I know you're Central Canada, more Central East Canada, so close to the French speaking people there, but yeah. Oh wow, all the corroded vias by wire, damn it. Let's check if we can still run it. Oh shit, okay, yeah, that's, look at that. That looks almost, I thought in the beginning, it looks like, yeah, this is power. Look at the thick traces. So this has to be some sort of power trace. On the other side is the regulator. So that's really weird. Maybe we have some noise on our alternator, high voltage noise, that's causing these charges to appear. Oh, okay, at least I don't have broken traces, but I would really love to see a broken trace instead of like the short between those. That could be the problem. If there is like a, wait, now I scraped it off, but we can maybe measure it somewhere here. There could be like a connection. Or degraded. The caps could have degraded as well. Yeah. Let's clean this up then. I need like, it's like normal toothbrush is not good enough. Where did I put my tools? I'll be back in a second. I have some other tools that might help. Like a steel brush, like this one could help. Be back in a second. Okay. Hammer. Yeah, hammer is an option. Oh, I have fine drill. I found some fine drills that we could like drill out vias or something. Oh, this is good. This is good. I think I found something really good. This might be the right tool for that. Let me swap the tip of this thing. I hope that fits in the socket. Or it might not. Oh no. Okay, here we go. It fits. Okay, great. Look at this. Eh? I don't understand this thing. What kind of asbestos polisher is that? Chinesium asbestos. Hello, who's there? Hey, Bricks. It looks like it's double-sided. Oh shit, this is... I think I need to give it more power, but I think it can only charge. Wait. Can it charge while... Black hole. Doesn't look like it's charging, it's strange. Okay. It's way more efficient than trying to scrape it off with okay, this is more strong corrosion here. Yeah, I saw the mattresses which are filled with glass fibers or something to be like memory foam or whatever. This looks not very healthy to me. It is covered. It's spilling on top of everything. So it seems like if we zoom in, you can see that. Let me zoom in. Okay, it's a little bit dark, so I would need more light on that. We bring it closer. The microscope has you can sometimes see that basically because here, where is it? You can see in the center basically the coating is breaking just because it couldn't span like this big hole. So it might be actually just an issue with corroded vias. Wow, super. But look at that. There's no way I can do this without. I should even try acetone. Look at this. This looks like carbonated. There's no way there is no short between those two. Oh, focus. Oh, sorry. Ford out of focus. Ford out of focus. Ha ha ha. So funny, Matthias. Yeah, this coating is gone. So that creeped underneath of the coating. Yeah, focus the fuck. Ah. That's alright. I won't miss it. Yeah, I'm also not watching. Look at that! Oh, here! I can imagine then that would be your dream job, to combine like with your electronics hobby with car repair. Like fixing actual PCB from your own car and then making it work in the end. I hope it works in the end. At least it should work for 1 year, because it won't probably pass the main check in 1.5 years anymore. So I need to get rid of it, sell it to Eastern Europe for them to fix it. I need more IPA. These ones are creepy. Look at that. What kind of spill is that? I need to record that. This is like super strange spill. Thankfully there are no like vias nearby, but regulator has, yes, 5 pins. Some sort of surface mount TO package. Okay, these were certainly somehow high resistance. This looks also like it could have had some high resistive connection. I'm wondering if like my brake light sometime coming on while my brakes are totally fine, it was like slightly dimly lit while my breaker fluid is full and the brakes are alright and there is no issue with the brakes. If that has something to do like with a resistive connection between like that trace and power or whatever, just coming on like randomly, like dimming up and down slightly. It caused me some worries in the past and could be all because of this instrument here. What is this? Yeah, this via on the other side is underneath the connector. I can fix that on the other side. I think I had different things to put on there on this tool. I mean, I could use, yeah, I need to get rid of that because there's certainly a connection here, like all the components. I don't need to test anything, I just plug it in and see what happens. Really? Also on this car, I mean, they're all perfectly fine. My tires are fine. Maybe sometime, like, okay, one tire was losing a little bit of pressure, but I don't have pressure sensors in my tires, so it has nothing to do with that. What is this? There's no way there is no short or anything. the focus. Why is the focus so narrow here? Infineon. Okay. We should check. Should check the datasheet for that. Most crunchy VS, yeah. Oh, this one is bad. They were cheap with the VS, and now we have the issues here. Oh, look at that. Everywhere I look. Yeah, that's carbon. Okay. Is there more? I think we got them all except for, oh no, here. Except for those here. I tell you, my brakes, I did my brakes 1.5 years ago. I completely let fix my brakes, like the cylinder and the back and everything. Brake jaws and that was also one reason why I did it, because they were locking, like the rear brake was locking because the cylinder was a little bit rusty. So I let's swap the cylinder. So with the brakes I'm making no jokes here, because I don't like to risk my life or whatever. Although I'm not using this car as the main driver, just only drive it to whatever I need it for the construction, transport of like materials and so on. And recently I transported more, like a lot of stuff from my from my Reno. This is ground and this is gunky. Alright. Yeah. Oh, that looks crappy. Okay, the spill, I need to scrape that off. This should be okay. Alright. Yeah. Okay. Alright. I think I will now try to get some holes. Some vias, the ones that are not covered anymore. Here. Yeah, I will. Oh, okay, that one. Doesn't, like the coating is still, seems to be. Interesting. Oh shit, I melted a pin. Here. Yeah, it's not that bad. Oh, I missed one over here. Let's see if it goes away if I try to wipe it with soda here. Yeah, wiping with soda or look at that. I think these are alright. Yeah, very robust cars, they shouldn't bend. Built like tanks. Oh shit, more stupid pins that are crappy. Ah! So my last main check for the car was 7 months ago, so that's still right. We have like a regular inspection every 2 years. The only issue that my car had was like that the exhaust, I think like basically the quality, exhaust quality was quite low, and my mechanic recommended to like use an additive to clean the motor, and he basically said that it's quite probable that that was all. We don't have other projects for today because this is priority number 1. Oh, wait. Huh? This blue stuff is on top of the solder mask. So we had gunk off, but there is still solder mask. Interesting. All right. Is there some? Yeah, we have somewhere bare copper. That might be here. Might be some bare copper or bare metal. No. That's also underneath the solder mask. No. Nothing to see here. Okay, let's see this side. We scraped a lot over here. I think this was before we had the IPA over here. Oh shit, I touched the plastic thing again. Okay, I'll increase the temperature a little bit. Ah. Yeah, it could be like iron. They are just riveted with iron. I want a $3,000 Chinese electric car. Oh shit, I touched up the pin. Yes, there is one. I think latest video of JP Performance. Is this the German channel name? They have like the sale value in Germany will be probably like the price with taxes and everything will be 10K, but still in China you can get it like from the factory for 3K, and it's not bad. I don't care as long as it's safe. This is not. This vias. The vias are terrible. What? Drive it here from through Russia? Nah, not really. I mean, we can ship it. I guess it's a matter of time when people start importing again, because our government just decided to reinstantiate the bonus that you get for buying electric and hybrid cars. Because I'm a little bit upset about like the hybrid. I hope they only do like plug-ins. Even that is not great. But if you get like 6K for buying an electric car and the car price is 10K, then you can just buy it like that. LFP, what is LFP? Okay, how do I power it on? Yeah, financiable. You can just overdraw your account to buy a new electric car. For driving it like to the next village for shopping, it's good enough. Ground to all grounds, or I just plug it in and we see what happens. I just can go downstairs, we plug it in, and see what's happening. What do you think? That works too? Okay. So now we need to set up some strange streaming functionality. Oh, Foo! Thank you! Thank you! Oh, Discord document? Okay, let me check. Oh! Shit. My camera is tipping over. Why? Okay, let me check. Let me check everything. Okay, this is the PCB now. Here we go. Connector. Brake light. Oh, do we have hot in AC? Huh? Wait, that looks the same. Tachometer. Okay, so it's the pin numbering. What pins are? The second document, huh? Wait. Didn't I click on that? That's the... Oh, okay, yeah. There we go. I didn't open it automatically. Okay, here. Foo! Again, what? Thank you very much, Foo. Very generous. Okay. Let's see. Ground. Switch to ground. Oh, damn it. There's too many grounds. Like, we have like to connect so... Oh, ground. Oh. Voltage supplied at overload protected. Return signal, voltage supplied, start and run, overload protected. Okay, that's 16, 14, 16. Yeah, that's what we saw. So actually, oh, look at this data link. Bus negative. Data link bus positive. not used. Ignition switch and accessory or run. Okay. Okay. CAN bus, yeah. Let's plug it in and see what happens. I will put on like the camera. What was the camera streaming service? Uh, like the chat. Only fan. You know what? Hello, hello, LCD. Yeah. You know what? Okay. Let me share. Oh wait. Where is what is the video chat? Not chat roulette. Ah, what is this? Where you just have a link. No, there was like a service, web RPC. I can use Meet, but okay, I can use Meet. I will use Meet with 2 different accounts that will work. I can't call myself. That won't work. Okay. Jitsi, yeah, Jitsi is what I thought about. Wait. I can. Okay, let me invite. Myself. Okay. I will go on LTE. I have 30 gigabytes of stuff. Disconnect Wi-Fi. Can I turn off Wi-Fi somehow? Okay, internet. Join call. Ah! Ah! Okay. I can't probably can't hear you outside. So maybe I can share a screen, or how do I do it? Okay. Anyways, I will go downstairs and and then try to connect it. Okay, let me turn off the camera for a short time. I'll be back in a second. Huh? That was successful. I don't know if you even can hear me. Oh no, you can't hear me. Ha! You couldn't hear anything, could you? Oh, okay, all right. Now I'm back. Yeah, I noticed. I should have turned on. I should have turned on the desktop audio. Silent movie. Yeah. Did you see it light up and it lit up? It showed the kilometers and blinker was everything was working. So our cleanup was successful. Yoo-hoo! Easy peasy. That's $50 saved because, and I wouldn't know if the new one is also good or not. I mean, if I buy a used one, there are no new instrument clusters out there anymore, and I can keep my original kilometers on the instruments. Yeah, I guess because it came gradually. I think it started. I saw the instrument randomly restarting while I was driving half a year ago. Like it happened like twice, 3 times, and then this week it just started turning off and on all the time. So let me switch here. Turning off and on all the time, and then I checked basically on online, and it's since everything was working, like the car was driving normally, it was suggested it could be the instrument, and I saw other people also on YouTube, like saw 2 different people fixing their boards by resoldering the joints here, and actually it was the corrosion, so it was only like some high resistive connection between pins that made it go in fault state and restarting. Now the only issue is if I can connect them correctly, so they will show like the right. I need to maybe recalibrate at least the speed. Yeah, it's a dashboard. By the way, Basil, hello. So, drop on the stopper. But what if I turned this by accident now? Is this like, does this have a stopper built in? Or is the stopper, or is this, it looks like, for me, it looks like the stopper could be built in this mask here. Like, do you see that? There's like this. Oh no. Okay, let's see if that works. Face. We can do like a bitluni face now. That's I can't put anything there. All right, so I don't know if I want to mess around with it anymore. As it works now, so I will just assemble it again, and then what, aren't there motor shafts keyed? No, they're just needles, like very thin needles, and that's why it might not work. Okay, I should maybe document a little bit of this the assembly again. So I think there is no step in. Is there like another step? No, I think this was like the first step. It will work for yeah. If not, I will just disassemble it and put it like dip it in nail polish. Okay, here we go. This is it. Now I have the markings where the new needles have been. Okay. We have to put it in the right order. Okay, so are those similar? Yeah. The tape is to mark what my I turned the needles. Oh shit, am I turning the motor now? Wait. That was, I turned the needles to the... why is it rotating? So what I did, I turned the needles completely in one direction. And then, but the limiter is physical here. Yeah, it probably comes back again, I don't know. Oh, okay, yeah, but nobody knows. When I turn it on, it could go somewhere. So I will check when I turn it on. I shouldn't have turned the needles, especially this one. Okay, I have an indicator light for my fuel. And the speedometer. So this is like the marking where the needle was at its limit. Okay. Oh, speedometer is slightly off. Need to pull it off again. I don't care. I mean, I can just pull it off and then turn it around. I will see if I... so recalibrate the RPMs isn't that bad. I mean, there is always... I know the power dip around 2000 RPMs. So I know where it's driving like 2000. I could also measure it with audio, the RPMs. And then I can also calibrate on the Autobahn. I can calibrate the 100 kilometers per hour or 50. I think more important is 50 kilometers per hour. I can basically drive 50 kilometers on the GPS. Like you turn on Google Maps and you have like the actual speed shown there. And I can check, okay, I have to turn the needle a little bit. So that's it. And the fuel control is... probably I just refuel until it's full and then put the needle to 1. How about that? So I can recalibrate that if it's not correct. But I mean, I was driving it without working indicators recently. I was slightly off, slightly too fast on the speed. Oh shit, I'm recording still. Okay. I should clean that up. I scratched it a little bit. There are like the clips, metal clips in the car. And I scratched it a little bit. So let me clean that up quickly. With this one. Is it inside? No. It's weird. Like it's fly shit. Oh, it actually... Still more corrosion. It's better than new. It will detect. Yeah, I don't care. I could change the kilometers on my. It's just a flash value. I mean, on the PCB, there was like this. The flash. Oh, this is gunky. It's like still very, very gunky. I don't want to mess around. Since I know it works now, I never change a running system. Okay, so this is the assembly. Bloop! Clipped in. And now, oh shit, I lost the screw. Okay, and this is the last one from the back. And that's the instrument, my friends. We are done. What? But where's the screw? I dropped it. Ah, here. Here. Wait, this is not the right tool. Ah, here. Ah. Okay, that's it. Woohoo! Nice. Oops. Okay. So we are 2 hours in fixing stuff. E-mark? What is an E-mark? ESP32 and use gauges as a sub-meter. Actually, I like the actuators on the meters. I'm thinking maybe I should use meters like that for doing whatever. Autobahn, yeah. Can buy them separately. Okay, let me check. Oh, really? Okay. Stepper meter. Oh, you're right. Here we go. Here. Ah. Oh. That's what they do. They calibrate in the beginning. They just drive to the maximum and then back, and then they step from the zero. So probably it really doesn't matter how I plug them in. They will always calibrate themselves in the beginning. CNC at 3D printer. They're cool. Yeah, okay. I mean, they're probably not that powerful, but it looks like, I mean, 2 coil steppers. Cute. Yeah, they must be weak. I mean, there is like, I mean, this is like spinning on this needle here. Oh, okay. We will see what happens. Mine looked like when you turn it on, it like does the sweep, so it might automatically like calibrate this way. As far as I remember, I mean, it's not just turning on. It does like this thing because it's old enough. Cool. All right. What else do we do? Oh yeah, we had the board, the dev kit. Yeah. So I guess it will calibrate itself. Everything is nice and dandy. I just fixed the car myself. Thank you, Dan. Simple Electronics. Everyone, share, subscribe, like to Simple Electronics because I learned automotive from him. It hammers the point and lower. Yeah, it could be as well like that. Okay, so oh, people, there are only 300 of this chip in existence right now. Here, this beauty. Baser, you be jealous because or envious of this chip. Let me put it on underneath the microscope. There are only 300 in existence, and I got 3 of those. That's my special present from Patrick, WCH Patrick. Here we go. Yes, WCH, and let me focus. Look at that beauty. Yes. Yes. Look at the pin count. Nice. Like AI enabled chip. It's amazing. Okay. I don't want to make it dirty. You saw it here first. You saw it here first. This is like bad friends. Quote. Dual core. Yes. So here is our here is the dev kit, and I think you can download it only like the environment. We can test it from Chinese side. Oh, my booster is running out. Let's see. Bluetooth chips or Ethernet chip, risk-free general series. Okay, let's see. Okay, peeps. Here we go. I need to scroll over here so we can see that. Oh, it's not. It's not even showing here. I have a better view. Where is the newest? Let me check. I don't want to overshare stuff because there are some confidential stuff, or at least not. It's not very confidential. Yes, it is almost system on chip. Okay. Let me. I need to hide something. Okay. Here we go. So I had some cost calculations for cores and can I zoom in, please? Let me zoom in. Okay, 200. Okay, cost calculations for basically RAM, power, and whatnot. And these are LCSC prices. Actual prices from WCH can be lower. Here is like the core name, and this is the instruction set. Oh, that doesn't matter. I will try to get it. Okay. Hey, Kasper. Winter's very mild this week. Last week it was like really cold. So it's the new 5VA. It has like a combined bit operations and floating point, and it has like additional, I think, instruction sets on like more like streaming extensions. And here, oh, why is this not showing correctly? Can I? Yeah, it doesn't show correctly. Okay. Do we have it here? 5A. Okay, in this list. I just got the lists of the official site. And you can see basically hardware floating point. Oh, they have all, like even the super cheap. Look at this one here. This one is 303. The cost is 64 cents. It has a floating point instruction set, 32-bit floating point instruction set. All right, I can even, I got like here, like random sites with data, and you can see like 4B V4F has integer division in 5 cycles. Then like interrupt whatever stack. This is the FC, yeah. So this is the version 4. And wait, yeah, very affordable MCU for that. It's like that is more suitable for the cluster. The only thing that I don't like about it, I think this is not a QFN. We would need to check it. Yeah, this is I think the 48 pin version, 37 GPIOs. Yeah, that's 48 pin, I think. Or yeah, is it? And it has limited RAM as well. But what I'm calculating here, okay, let me turn it off. I probably, yeah, I need to hide a few calculations. So, oh, yeah, that over 35. Okay, I don't have the calculations here. Yeah, but the host capability, yeah, that's right. You don't have that on the 570, but the 570 has native. It might have host capability. I don't know. But if you see here, like the processor count, do you see that? So if you would like dream of a cluster with those cores, and you do 65,536 cores, the total cost on LCSC, 13 cents per core, is 8.5K dollars. By the way, if you use GCC 15, it's more optimized for this core because, yeah, that one also, the interesting part compared to any of those here, which are Quingy, you can see here, Quingy 2A, 2C, I think, they have like an instruction set. Wait, Firefox tab crashed. Yeah, here you go. The 2C has hardware multiplication, like to some extent. That's just a subset of multiplication. But all the small cores like 003, 2, 5, 7, they have only limited instruction sets. But starting from the V3, they have hardware multiplication. So my cores, my clusters that I made before, like this one here, the GPU, M.2 GPU, or this 256 core bitluni Force RTX, yes. This is the 256 core cluster. These were without hardware multiplication. Terrible, terrible. And you spend only 3 cents more per core, and you get the Queenie 3C, which is most interesting part. It has like multiplication, division, and did I have, wait, no, I don't have it here, but it has multiplication and division, and I think on the sheet that we saw here, no, that's all 4. They're not very fast with the division. They might be even slower, but they can do hardware multiplication and division, which the smaller core wasn't able to. And interesting, they have bit operations which are not available on the other ones. So like V3A or even V4A, they don't have bit operations, or they might be, I don't know where they are built in, but the bit operations do stuff like counting leading zeros, which is very important if you want to convert to floating from fixed point arithmetics to floating point values. And when I implemented the ray marcher, it is, yes, it is now. So I checked it. The bit operations is final, and the most crucial one, I think it is even mentioned on Wikipedia. Not that it's the most crucial, but what is very important about the bit operations is like counting leading zeros. Because if you like, what I was doing, I needed square root reciprocal, which is just mandatory if you do ray tracing, shading, or whatever, distance calculations. So square root reciprocal can be calculated also with Carmax or the Quake fast square root reciprocal, but that's done on in floating point. So you have to convert to floating point, do the bit magic there, and convert it back to fixed point. And the conversion from integer to floating point, you need to count the leading zeros to have like the right exponent bias, or to set like the correct exponent. And if you don't have that in your instruction set, that takes you like several cycles. I could even show you the code. I think the code was public anyways. Let me check. What is MMU again? Can it run? Yes, certainly could be running. It has, I think, protection, memory protection areas. No, the V3 can have protection areas. So I think you would need, like running Linux, you would need like the beta cores, because you need protected area for your kernel or something. Supercluster 2, I think it's in that one. Yeah. Okay, here, cluster ray marcher. I can show you the source. So I'm not a blender. I actually did this crap, and fixed point. I think it might be here. Okay, so we have all the calculation, fixed point arithmetics. Yeah, which is this is the leading zero count. So basically this function has like 4 branches to calculate the leading zeros, at least 4 branches, and then do some more. So like calculating leading zeros was here. It is done whenever I need to convert to floating point, and that takes like a bunch of cycles, more than an integer division on the newer course. So this is really bad. And here you can see how it's basically converting. So it counts like this is like this. Yeah, it has to ignore the sign of the fixed point and does some mantissa calculations. That's the I, whatever. So this has basically been flowed to fixed. And okay, this doesn't need the leading, but this is basically the function that's implemented in hardware with the bit operation. So having the bit operation instruction set is really great if you don't have the floating point unit. And yeah, this is the magic numbers, the Quake fast square root reciprocal, and I needed to convert it here to do the magic, otherwise it wouldn't work. Oh, you can run Linux? PS RAM? Oh, okay. Yeah, it's very slow then, isn't it? I mean, you don't need a floating point unit there. You can emulate everything. Yeah, so yeah, this is very slow. This is only square root. I mean, even multiplication is emulated here. So that is, you can find it on Supercluster 2, Ray Marchand, and Fixed Point. 20 minutes to boot. Hey Juan, we just fixed my car, so we are done for today more or less, but I will try to download the CH32H 4417 SDK and maybe check an example for that. We could also, what I would also like to do is to test how fast that CH70, how fast it is compared like with the integer multiplication and division, how many divisions and multiplications we can do per second. That would be interesting. I don't know if I have a dev kit of the O3. I would need to take some of my boards there, but they are harder to use. Anyways, yeah, that was the short side story about these ones. So making a cluster of this many MCUs costs 9K. And let me show you something else. How would you, where is it? Where is my, So how are you going to fit 65,000 MCUs? Okay. So this is 16 by 64. These are 16 MCUs, bigger ones. These are 16 by 64 MCUs. These are sockets for PCB edge connectors. And these are 32 of those. And yeah, the back side is missing. So imagine you have 16 times 64 times 2 times 32, then you have your answer. And this container size is 30 by 60 centimeters. This is how it looks like. Fan cooling, yes. Yeah, in this star configuration, either fan cooling or liquid cooling, liquid submergent cooling here. But what I learned is that, oh, maybe you're familiar. Yes, mineral oil is one of the options which is safe, but gross and hard to transport. So fallback is air cooling, but there are like low viscosity fluids. There have been for basically this purpose, cooling like circuits, but these are discontinued because they are PFAS. Damn it! I need a like low viscosity replacement for like the coolants. There are some I think there are some like distilled water distilled water is not recommended because it is not, I think it can be charged, and then also some minerals can dissolve in it, and then it will basically corrode everything. It's also like it could just like destroy the PCBs. That's what ChatGPT said. Let me check with ChatGPT. I can show you what I. Okay, here. Okay, so blah blah blah. Research. Okay, what transparent coolant can I use to cool circuits without corrosion and shorts? Okay, this is it. 3M Novak engineered fluids and 3M fluorinated. Okay, but there's FC72, FC70. It has no iron, so it absorbs them. Yeah. So these are basically PFAS, and they're not produced anymore. Then we have drawbacks, very expensive. Don't care. I mean, if I pay like 10K for a cluster, the few $100 for some coolant won't be that bad. What is it? I mean, you can calculate the volume of this container. How many liters do I need? 6, 12. Oh, okay, that's 30 liters more or less. Mineral oil is one option. Thick, poor, heavy compared can form bubbles over time. That's also an issue. If we like pump it, it can hard to clean off PCBs later. Yeah, so you would need like to use IPA to like get it off. Can degrade plastics, rubber seals depending on formulation. Yes, or you have to fill it like in canisters and then fill it when you have it shipped or whatever. Silicone oils like stable, non-conductive, higher viscosity. No, okay, not more expensive. Okay, silicone oils, that might be an option. Distilled water, here it is. It becomes eventually conductive, dangerous. Okay. Ethanol is flammable. I don't want to do that, and also evaporates here. And glycol coolants, conductive and corrosive over time. Okay, Novak. And then I had good. Wait, is one PFAS? Was my question. Blah blah blah. Alternatives. Poisonous. And I think there is like a drop-in replacement. Yeah, so Novak, what it recommended in the first place is basically PFAS. So that is toxic. We don't know yet, but it's like never dissolving. It's probably West Solve Zeta. What is that? Solvent saved PFAS free M3 Novak replacement. But what's the okay technical data sheet? Zeta common applications. Defluxing, cleaning, okay, but I don't know it. I think the issue with the replacements were that they are not certified for like long time duration or something. Yeah, here is also fluor. Everywhere we can see fluor, it's probably not great. Zeta fluor free, PFAS free. Flux removal does what will cleanest ever, yes. Bromine, decreasing metal, blah blah blah. Cleaning performance, okay. I don't care about cleaning performance. Boiling point 54 degrees C. That's terrible performance. That's like it will basically boil off. Or like if you have, it will start to evaporate. It needs to be like very efficient cooling, and if you have sun shining on your container, this will basically evaporate already. Energy density so low. I can show you my calculations. Wait. So what has been decided on, because I'm not the only person involved in this endeavor, I'm getting help because yeah. Oh, wait me. Let me check the power calculations. Okay. Cluster count 64 count per cluster. Total power is 1300 watts, and that's only the MCUs. That's only the MCUs, and I mean we were talking about like low LED power. Yes, but if you run it like all the time, I mean, we can get the power out. I know, like 1.3 kilowatt, but decisions have been made that RGB LEDs should be built in, which are like the blue one is, let's say the average voltage is like, let's say 2 volts, but usually it's a little bit higher, 2.2, because like the blue ones need at least 3 volts. What is the lowest forward voltage of the blue LEDs? And then we have, let's say we run it at low power, and then we need like 3 milliamps. Then cluster count. Wait, something's wrong. Current milliamps. Okay, what if we do 30 milliamps? 5 kilowatts. This is like full power LED. The cost isn't right here. No, that's not full power. That's like 10 milliamps per color. Yeah, so basically if the cluster runs on full power, oh, that's 65,000 LEDs. My big wall, you remember the wall V3, which was, how big was it? It was 1600 LEDs. So this thing will have like 50 times the LED count compared to my biggest LED wall. And this is like 3D volume, star-shaped 3D volume. That's. I need to check. Where's my on shape? Where's the on shape thing? Okay. Yeah. So here, you can imagine. I couldn't like on shape somehow like does. If I do the instance, I could add, I think, if I use the linear pattern here. Wait, no, this linear pattern. If I do that, I could maybe, no, I'm using, wait, add. Yeah, it does a copy of that one device, so that's why it look. But you can imagine this could be a volume. At least if you look at this, it will shine like to the side. It's probably not even necessary, like to have it like glow very, very bright or something. But it will be, like the PCBs, I don't know if this will even work. Look at that. The PCBs might be very close to each other. Okay, let me, turn off the container. Let's select that and do the array here. Yeah, we can calculate the lumen. It's certainly like a lot of power. Someone suggested, oh yeah, so what's the name? We had a new visitor on the weekly hangout, and they suggested not linear pattern. What am I doing here? Circular pattern. Damn it. Cluster axis is, can I do the axis? Instance count 32. Yeah, I didn't watch that yet. Styropyrus. What is happening here? Why is this? Why is there an array? Wait a second. Something's off here. Huh? What did I do? Let me rewind. If it even works. SPI. I show you how. Undoing change. Uh-oh. Shit. I clicked too many times. I just wanted to do like a circular pattern for the PCBs. I can show you in Paint. Yes. Okay, here's how it works. Pop, pop. Okay, we have Ethernet. We have either Ethernet here, base 100. Ah, no. But one more important, okay, let me remove it. Okay, we have USB 3. Then we have 417, this dual core thingy, which has no, it doesn't show it here, but I think it has also 80 GPIOs more or less. It doesn't show it here. Yeah, I think it should be around about 70 or 80 GPIOs. I don't have it shown here, but this is basically eep, 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 eep. That's 64 chip selects CS and then SPI. So okay. I had to refresh. It will be fast. I mean, it's USB 3 and we have 450 megahertz here. So, I mean, it's as slow as 100 megahertz. The SPI speed might be 80 megahertz or something. And then we have here basically this layer. So this is level 0. Oh shit. Okay. Level 0. Then we have level 1. Level 1. Wait. 303. Dip, 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 dip. Then we have beep, 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 beep. 32 because the cheap one has enough for 32 303, 64, 37 GPIOs. Good enough. 32 times. Chip select SPI. Then we have level 2, another 303, 303, and then 32 times chip select SPI. I think the design on CUDA is similar somewhat. It's a long time ago I looked at it, but it is quite of some levels here. Yes, that's it. And then we have basically level 3, which is the last one. And that's, for example, the 570 question mark, or is it a new option there? And this will be basically, this is times 1 times 64 times 32 times 32. Ah, shit. 32, and this is 65,000 whatever. Doop, 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 doop. Doop, 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 doop. Interesting part about this is, oh yeah, and here we have beep, beep, beep. R, G, and B LED. Interesting part. Coincidentally, we have one SPI for the 570, one SPI interface. Then we have two SPI interface for the 303, so we can talk down and up at the same time. So we have a constant like update stream to, we can like stream to the host here while collecting data from all the clients down further down, because like one transmission takes longer up there if we consolidate in some way or form, and that's quite good. And this one has like quad SPI, but I don't think the 303 have quad SPIs. We could check, but I don't think they have quad SPI. Let me check that. That would be nice. FreeCAD, yeah. Okay, let's see, what do we have? Yeah, it has a 10 megabit controller for Ethernet. CAN interface. Three SPI interfaces? Is this the right document? Yes, it is. Okay, I was wrong. But what is this? Characters pinout specification. Okay. What is I to S2, S3? What is I to S3? Maybe we can do a better connection, like multi-line connection, so you can talk faster. Thank you, Wikipedia. Yeah, I think there is a... Maybe they support just multiple channels like stereo and I3C. No, I don't think it's I3C. Is it? Okay, let me check. Reference manual. I think the reference manual is the same like for the pop. Yeah, it's one reference manual for all. We got them downloaded them 1,000 times. This is the 7th version that I downloaded here. Okay, let me check. You can zoom in so you can read as well. SPI. Okay. SPI supports data exchange in a 3-wire synchronous serial mode, and the chip select line supports hardware switching between master and slave modes and supports communication with a single data line. Okay, it is also 3-wire synchronous serial interface connection, supports 4 audio standards. I to S. Okay, yeah, that's what's meant by that. Full duplex synchronous serial mode. That might be interesting. I mean, the full duplex part. Okay, and we can do half of main clock, which is 144 megahertz, divided by 2 is 72 megahertz. You never know if there is a new version of the datasheet. Yeah, DMA transfer is quite nice. I to S features. Yeah, it's not that great. DMA transfer, okay. Mesomosi, SCK, that's clock, and chip select. We have 4 lines here. I hope we have enough communication. Oh, will it? Okay, so that's that. We have now actually data bus architecture. Anyways, if you see what we have here, basically, if you calculate on our levels, so these are here fun MCUs. They can do integer multiplication, division, and bit operations. So quite good for encryption, hash calculations, maybe emulate like do like basic shading, can do also like emulate floating point but not as quick. But then consider that we have like the lowest level of our 1 core per pixel. That was the idea. Each pixel doesn't need to load like new array information or whatever, or if you have like binary space partitions, as long the view stays the same, it has only like this, so it might even like the memory of it might be enough to store like all the triangles that it is capable of clipping. Or I don't know. Anyways, if you look at our sheet here, on this level here, level 2, we have already 64 by 32, which are, where's my on-shape thing? Here. On-shape recovered. So these here, container, turn off container, okay. These here, these are 16. Wait, is this correct even? It might need to be 32 of those. Yes, we need like 2 more rows. That's not correct. But we have, I think in the container is still more space. So you can get glass containers in this size off the shelf as a vase. This is basically a vase. So from the dimensions, that still might fit. Look at that. We have some space down there still. These are actual dimensions. This is like the 30 by 60 centimeters container. That's a glass vase that you can just buy off the shelf for $50. Yeah, it's all there. Yes. But so what we got is 32 by 64. In that case, we need to put 32 of those on one side. So this is not correct. We need like 2 more rows. So this will be quite a densely populated board. We have slightly more space toward the center, but not much. If I want like some actual flow of the liquids or whatever, or I need to take a bigger container that's not off the shelf, or like I need to search for more vases in other shops. I really don't like that it's so tall. 6-layer board. Not really, because okay, for the power maybe 4-layer will be alright for tracing power. And then, oh yeah, you're right, look at this, 64 individual chip selects. Individual chip select on 8 millimeters. That's not possible. So this design might not work. In the end, we might need like a container that's twice the diameter and half the height, or both ends, or having the cores on the side here and the MCUs on here. That would work. Yes, power and ground, but there are multiple powers and multiple grounds, because we don't want any LDOs anywhere here in this thing. We don't want like addressable LEDs, because they will burn. They will like take 3.3 volts and then basically convert everything that's exceeding the 2 or 1.5 forward voltage for red one. They will convert it just in heat. So we will have a power for all the LEDs, individual power line for green, red, and blue, which will come from the new power level up there. Yeah, so there will be like power for red, green, blue, core voltage, and ground. So at least 4 different powers for this board here. Might be even like 5 for the cores here. Like these cores need higher power than these small cores here. Yeah, or they share, like the LEDs might also work with, but I really don't want like to share the power between LEDs and MCUs. Yes, Foo. I think what we need to do is we need to put those MCUs here. So let me remove those MCUs to the side, and then we only have like 4 rows per, wait, what, 32, that's 16. Oh no, that's only 2 rows. Oh, per MCU. That will be tough to fit. But the wiring might fit there. We have a little more space. We can do 10 centimeters. No, we're not taking those. We will take some drop resistors and use directly. We will use like high side. Is it the anode? Anode will be individually powered, and then the ground of the MCU. So the MCU has to drop some of the, like. Will that work? Yes. Yes. It will just conduct power, but the voltage won't harm it. But if the core runs at 1.8 volts and we have connected the cathode of the LED to a GPIO and the anode to like the individual voltage, like 3 volts for blue and so on, that I think that will work. Will it? Or am I wrong? Oh, only one color, like gray. And then I zoomed in. You know what's crazy? These are 1000. That's only 1024 MCUs here. So this front and back. Oh wait, if we have front and back, we need more layers then. 65,536 cores in total, plus 2048 FPU cores. That's what I wanted to say here. So 64 by 32. So this level here, this level alone, will be 2048 cores that have a built-in FPU. So I would say ray tracing cores. 42. And there will be like another 64. Blue? What? What blue? What? I don't know how good it is. I mean, the bandwidth, communication bandwidth will be the slowest, because in the end there is only USB 3, and we have also like the bottleneck. The bottleneck is, I think the bottleneck will be the communication between those 2 layers here. Oh, the LEDs, yeah. Wait, what did you? Oh yeah, the first, yeah. We have now decided to go full RGB because Let me show you. Come on. Because we need blue. We need blue. Come on. I wanted just to show you Cherenkov radiation. Okay, here. Here, peeps. We want to see that. We want to see that when we turn on our reactor. Here we come. This is what we want to see. Foo! This is the design. This is the design. This is the design. That's why we designed it like that. Look at this container here. Look at this container. The arrangement, everything about this class. RGB, no! It won't be just an RGB LED matrix. It will be fast supercomputer. No, GPU. I don't know. I want this GPU to have each pixel has an individual MCU. This is my goal. Oh, please, no more than one iteration. But here is the goal, very ambitious. You will be part of it because we will design in the upcoming weeks and months. We will design individual test units. Yes, this is one issue, programming the MCUs. So the Linky, since we don't have USB on each of those, the Linky, where is it? Where's the Linky? Here, I have some Linky. Okay, the Linky is also a CHV3 whatever MCU. We need to put this protocol, or like the implementation of the Linky protocol, and basically forwarding through all those MCUs here, all those levels. And what we need to test is, we need to make AGI. No, there's no, nah, that's not enough RAM for AGI. 65,000 neurons is like yeah, we can do that. So what we will do is the design. Yes, I think so. I mean, we will just do some sort of, okay. So our first test will be, it doesn't need to be the same shape, but maybe something close to it, will be to test a cluster like that. Okay, so we need CHA32H17 and 64 of those here. 64 is the cost is like manageable. Then we have this level here, this is stage 2. We need to find out like this level or only this level here. So I think rather this level, and then have like a connector or whatever interface, because this here can be put on the round PCB where this plugs in. So if you look at that, I do everything here on this project. So that will be probably a sandwich board, because these connectors, like the edge connectors, I don't know if I will use those or more dense ones. Yeah, they take a lot of PCB space. There's not enough space to put like the 2 MCUs here. You would need like to have like 2 of the CH317s next to the connector here, and then have everything wired and whatnot, and the power as well. So probably there will be a sandwich board around one. So the first board, oh, all right, that's cool. Okay, so let's take that. Maybe I will ask Charles or people who are familiar with that to assist. Fu, has your name changed? Is it longer now? Anyways, so we will probably make the design somewhat circular or octagonal or something, or square that fits within footprint, a round footprint like that, that could be interfaced with this design later. And we will test basically this level, and then have, the longer the name, the longer my pain. What? And then we have like the SPI. Yes, Christian, that will be somewhat like that. Submerged cooling, and we will make we can do at least, I don't want like all of the, I don't want to make the whole PCB here, but I want to make like one unit which is 1 MCU and 32 of those small ones, just to test basically this level here and this level, and then we can interconnect one SPI to one level of here. So we have more or less, before we do a complete run for those, for all those, let's say this is the lowest level, doesn't have a lot going on. If one of the MCUs is able to interface all of those, program them, run the LEDs, we can do power measurements and basically check everything. Yeah, I know. Cray was one of the inspirations here. I don't know who mentioned it. Maybe on this stream someone mentioned it, Cray. Maybe it was you. I don't know. When we talked about the cluster before. And now or it was on the Hangout, like Cherenkov radiation emulating Cray submerged water cooled or submerged cooled supercomputer. Yeah, if we measure that and we are confident, we can then manufacture, or I can manufacture the board and only populate one section of 32 MCUs with this one, which won't be expensive, only the size will be expensive. Yes, I know. That's why I want to use the edge connector here. So we can also manufacture like 2 boards of those or 4 boards, and since we can plug in only like 4 and then test it and see everything works, we can do more and more, so basically more and more dense, and then finish that up. And since the other one, the circular one, yeah, I think there is only one off and it's not that hard. We have the 417 MCU, I have like 2. Oh, don't worry about that. The WCH chips, I will get them directly, like prototypes from WCH. I won't diminish the stock from LCLC or anything. This is already taken care of. So the 417s, they are not available and I have them here. And the lowest level, these ones here, the 570, there are, WCH has millions on stock of those, the 570, if I will use those. Yeah, mortals. I don't know if this will work. Anyways, these are the current plans. I think, yeah. Oh, we wanted to download like the development kit and test stuff here. Or do we want to check how many multiplications we can do with this oh, the 570 or the 417? Yeah, so I think I need to move the MCUs to the side here. How big are the CH317 LC? No, not 317, 303. Oh, they're 1 centimeter across. That's okay. 64 pins. Oh wait, that's the wrong one. I wanted the smaller one. But this is already like the large quad flat pack. Compute plate, yeah. Where do I, not RTC. Yeah, 64, that's 1000 plus. And that's, oh no, that's the lower pin count version, yeah. That's also not enough in stock here, so I wouldn't be even able to manufacture the 2000 MCU, so I will get them from WCH directly. Saturate the USB 3 connection. No, the top speed is I think 800 megabytes per second or something. Wait, let me check my notes. There have been performance tests already. No, 450 megabytes per second is what we can do over USB 3. So I have all the details already. But the issue is, how do I get 400 megabytes per second? Wait, is there like CH32? Where is the datasheet? Is the 37? Okay, let's test, let's check. Maybe we can collect from multiple MCUs at the same time. I mean, we have 4 SPI controllers here. Quad SPI times 2, but the other ones can do only... Okay, so we can actually do what we can ingest from the lower levels is basically 4 times 72 megabit, 4 times 72 megabits. 72 times 4 divided by 8, yeah, 36 megabytes per second is what we can ingest. The USB 3 won't do much this way. Maybe we need to do bit banging instead, like trying to oh wait, we only have, we only have a limited GPIO count for the data lines. Oh, okay, well, how many GPIOs do we have here? That's why we need to do a prototype first. Single wire protocol. Resistance. Data lines so long and shared between so many MCUs. Yes, that might be an issue. We might share it across 16 MCUs if we use 4 lines. So if we use, like, I mean, we have 4 SPIs. Let me do the course here. SPIs. That's wrong. No, here. 4 SPIs. So we would have 64 on this level, so 16 cores, and they are spread across, but they're not long. If you look at this file here, where is it? Oh yeah, the lowest level might be an issue. I'm not sure yet. So if we put them here, so this is 12 centimeters and 32 MCUs. That will be the maximum. So the capacitance might not be as big. Certainly not greater than the capacitance I had before on my, I think this one will be similar to this cluster. Then we have, like, if we split, like, each SPI has one quadrant here, it's also from the main MCU to these MCUs, depending on where they are placed. It will be also, like, I don't know, it's like 10 square centimeters, or 10 by 10 centimeters, all the MCUs that are connected to one SPI. Might be not that bad. I mean, the SPI bus has a maximum length of 1,000,000 kilometers. But this is what we want to find out. That's why we will run the tests on the 3 levels here. also like parasitics and everything that needs to be tested. It will be a big challenge. The greatest. It was my nemesis. It will be my downfall. Level shifters with. Yeah, if we need it. I really want to like limit and possible. Cause we will test it. If it sucks, we will improve it. Let's start low first and then. Are you worried, Fu? Okay, that's 1 centimeters, 8 millimeters across. Is this really so small? No, it's 9. More like 9 millimeters. The flatback is 7 by 7 plus, yeah, more or less, it's like probably 10 millimeters. We can make a footprint of 10 millimeters, but then the vias will. The mega cluster, this one here, we had problems with that. I can't even remember. My brain is. The biggest problem with that cluster was the program sharing the programming pin. That is the issue. I think this will be a challenge also, like the programming interface. Not sure if we want to use like the same lines for the programming interface as the SPI. If we can like repurpose the SPI level, the SPI pins in the clusterfuck. Yeah. Okay, 9 millimeters. That's, where is it again? Yes. No, it's alright. That stimulates me. Stimulates me to identify possible risks. There's risk mitigation before they happen. Before the clusterfuck happens. But I think the good way would be to start 2030. Oh, we have 4 months. We have 4 months to make it work. This is all budgeted already. So all the planning and design and sourcing and everything, financing has been done in the past 2 weeks. And now I can start like from next week. Yeah. I need still to make a video, but we can start to design the 417 board, to do all the stuff. Just order the PCBs from China, and then continue with them with this board, and then this one we can even like order assembled. Oh, nice! Thank you, Fu. This one can be even assembled from JC. They are sponsoring anyways, so I got my bag from China here. The only thing I need to consider is that there is Chinese New Year, and that would be in February. So March is the last. Is the closest I can get to do mass production or assembly of that. Think end of January I have to fix things with WCH to make the stuff happen. So this will be interesting. And all the power that needs to be figured out as soon as we got the measurements. that will be also interesting. Like, we need some serious power supplies here. I have no clue. That's like 3 kilowatts or whatever. The LED wall had 600 watts. Was it 600? And the power supplies were big. I think we can work with PC power supplies, multiple ones, and then just convert, like, step down. Drehstrom auf my oven, yeah. Now we can do. If they forget where they work. Yeah, we can pull 3 kilowatts, I think, from one wall plug. Like one phase. What is it? 230 times 16. Yeah, that's 3 kilowatts. So that's our goal, to stay on one phase. Otherwise, it was also suggested to use like batteries. I mean, you can always pull a lot from lithium-ion batteries. Then it would be standalone. Ten amps using Shuko. Yeah. So momentarily it can be 16 if we turn on the LEDs like medium power. Not full power, but medium power. So my partners on this project, WCH, I mean, I met with Patrick. Patrick is basically CTO and responsible for the international marketing and distribution. So we got like the bag from WCH, which is amazing, because as of now, as of my information now, we won't get in trouble. Yeah, he is. We get support like sourcing the chips and everything, and then of course Altium, which is funding the project, which is like the biggest scale project I ever did so far. More or less, there was like one that was coming close from like the manpower, but not like from the material effort. And basically the scale of this, I don't know, this is like, I think I will stop at this point, or I will outsource everything from this point on to actual engineers. And I also got some support from like, I can request additional support from script language. I don't know. I just got familiar with Onshape for the mechanical design a little bit. It's a little bit weird if I want to do arrays and then it doesn't like group them. Probably there is a way to put it like one object or whatever, but this is a mock-up anyways, like this PCB, because Altium will design will make the PCB design, and then also like this one, the connectors and everything. The only thing like will be the mechanical design, and for the conduits and all the mechanical and cooling part will be designed in Onshape, as well as like the container and stuff like that. And that can be imported into Altium. Yes, Rohan, you are only 1 degree connection. But if you join like the WCH Discord, you can directly even talk to them. So they're quite accessible. Yes, so infinite code for importing infinite CH 32s from WCH. Yeah, the WCH is yeah, they improved a lot when they introduced the RISC-V cores. No, the PCB design will be easy. With Altium, I can even auto-route if I want and do the calculations for impedance and everything. So actually, I think that's what the intention is, like to promote a new pricing model as well. But I don't spill any details here. Ricardo! Hello. No, I can't. It's confidential. Sorry. I think I even every with an edge connector like this ones here, like the old school ESA ones. 0.1 inch pin pitch. I like them. I like them. I like them. I found even ones without a key, which is cool. Oh, oh. Okay, I'm tired. Now we sidetrack. Then you mean Altium? I, 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 I can ask my contact to Altium, WCH, or whatever. You can always request samples from WCH. Like you will get the dev kits. They even encourage on the website, I believe. So like the 570s, I got some samples sent to. Oh, you can't code. Yeah, I don't know if you have like plans. You can certainly request samples of new MCUs. Like this is the 35 MCU, and that's basically a microcontroller board. It has like the USB and then trying like host samples or whatever. Yeah, that one has host mode, and then just trying some samples and I don't know, designing whatever with that. You can still do it, or design a PCB, or just a dev kit. They provide like the schematics for the dev kits. They are all part of the SDK, and then you can just copy the whole dev kit schematic, put it in a proper shape of like a PCB friendly MCU board, and then you have a new nice and dandy I don't know, board that you can sell or whatever, publish. Yeah, the biggest bottleneck, it seems, will be the communication. I mean, if we do like if we have like one MCU per pixel, there is only 60 pixels per second to communicate, like colors. So that's 64 times 3 bytes. What's the throughput rate? Let's calculate that we need for that. Times 3 times 60, 11 megabytes per second if we do like QVGA resolution will be will be 60 frames per second. And we calculated our bottleneck right now, if we use 4 SPIs, no bit banging with yeah, if we don't do any bit banging with the 417, then we have what was 72. Let me calculate. So 11 megabytes. What was like we calculated it before, was 72 megabits times 4 divided by 8, 32, 6. Okay, so we can do 180 frames per second, more or less. Or a higher resolution with 60 frames per second. And then just do all the load here. Not very efficient. Is it not? Actually, it's quite efficient. Okay, consider that, Fu. We are thinking loudly here. We have the chip select lines that we can use for bit banging. So basically, each cycle, or I don't know how fast the bus is, we can read, okay, 32, it is like a 32-bit processor, but we can read 32 of those lines with one read operation if the registers are distributed, the GPIOs are distributed well enough over the GPIOs on the registers. With like 2 read cycles we can read basically the whole thing. And if we use in this SPI, if we use like the MISO or MOSI line as the clock line and the chip select as the data in line, so just reverse everything, we can read all the MCUs or 32 MCUs from this level at the same time, and then these are just scrambled. They're like each bit is a different MCU. What we need to do is then like unshift it to, okay, this is 1 pixel, this is or whatever, like the data is now like shuffled, and we need to unshuffle it, and we have, what is it, 450 megahertz on one core, while the other core can do the read operations at the same time at the maximum clock what these can bit bang out. So actually, if we don't use SPI is the comfort mode, we could read in way faster than that. We could read in here, let me calculate. I don't know, like worst case is we need like, could you use my donations? Fu, certainly. I mean, it's funded already, but I can buy food to nutrition my brain, to design it, like we can put it in a fondue fund and then nutrition my brain, and we will design the boards together and think about the cluster together. Fu. You want to see your name displayed on this huge RGB matrix running around on the PCBs, like here. We can put an 1F here, and then you, as many U's as they fit, and then put it like in run around or just fill the space. Is this what you want? We can do it. You're always around. No, actually, this is proven fact. Test things. Check all the old streams, sort them by duration, and each of the streams that are 8 hours and longer, or there's I don't know if how many there are, but like anything above 4 hours, there is fondue involved. This is the only way to make me like work through, like, I don't know what was the longest, 12 hours, 16 hour stream was the longest one, which is probably uploaded in 3 parts or 2 parts, something like that. No, I'm not a no-named cat. I just want to give you something for this project. Fu, I always appreciate your donations. Thank you very much. You're a great support. You don't need to donate money to like fund it, because the funding is secured. But you can always support me with your advice and with fun money. Fondue money, fun money, whatever you like. Thank you very much. I'm really grateful. Ford repair money. Yeah. Ford repair. Yeah, I can buy for that like additive, my diesel additive to clean my motor. Or this is like brakes repair money or something. I will check if the brake light still lights up, but I think it might be actually like leaking current or something in that case. I could look at the PCB and see if anything that has to do with the brake lights was involved in like the creeping corrosions there. All right, my voice is almost gone, peeps. We wanted to test things, but yeah, we want to. Okay, one calculation here. I want to do one calculation. Let's assume we can read 32 bits at 40 megahertz. So we have basically 4 times 40 megahertz, because bus speed or whatever, for whatever reason. And then it's sponsored, yes. So I teamed up with Altium to basically be able, like Altium and WCH, they're securing the funding for the parts and even for sponsorship for the video in the end. Not WCH, I didn't want money from them, because I'm just convinced that I'm not a sellout about the tech, really. I love the chips as they are, and I'm just grateful that I have such a good relationship to Patrick. We actually are friends, considering Chinese customs, because we were having beers in the evening together after the meeting on Wednesday. So that was actually cool. We went to the Christmas market, and Patrick apparently didn't like Glühwein so much. So like that's the Christmas market, the German Christmas market with like herbs and hot wine with herbs and everything. Altium will be, yeah, they enabled me 1 seat for a year, but and that's only like the side effect. But there's I think they are about like to improve things for users like we are. What happened here? Oh no, I damaged my floors on the floor here. So actually I'm happy that I teamed up with them because I had people who said, "Oh yeah, Alcium is so expensive. As a normal user, you would never be able to like afford it." But they want to change that. So that's basically that will be just an ad, and they want to see Altium basically be involved in making like the complete project and being able to show it. No, it's way cheaper. I don't know if it is confidential, but there will be like a new price model. Yes, I think they have something like that. Um, I'm not I'm really I don't know all the details, but I talked to them and I know it's not like it won't be as expensive, and I think there might be an educational pricing or like an hobbies. I have no clue. I can't tell you, but yeah, basically what they want, they integrate like the whole CAD design integration, like with I don't know. I can maybe show if you. Oh, you were paying that? Okay, where is it? Oh, I'm not signed in. Ah, come on. Circuit maker, yeah. Oh, come on. So you're familiar. You will be a great help then. And I need to. Sorry, I need to sign in first. I didn't have time to play a lot, but Altium develop. Here we go. So it's not an ad right now. I just because we were talking about that. So here a workspace is 1K a year. Collaborators is free. Like basically, if I add someone to the project, or well, just without like editoring or whatever. So that's like yeah 960. So they changed basically the pricing model from what was like that. I don't know who if that's updated for you or it's just a different license. That's basically what I'll be using. Altum develop and it's 9. Oh, come on. Mm. I think I have the wrong browser. Let me check it. I've right. I think. Huh? Where is it? It doesn't let me log in right now. I don't know what I did. I think I used like my regular Google login. Don't see the password. And it seems like Password Manager doesn't have the password anymore. Did I store it there? Okay, never mind. I won't log in. But you saw like, I mean, there is like this licenses, $1,000 or something per year, more or less. So that's about that. Anyways, do I have a Linux version? I have no clue. I really don't know anything yet. So I need like for the details. As soon as I will do like the integration or whatever, there are like not many requirements. I mean, I don't talk about contracts or whatever, but I'm really free to do this project however I like. The only thing is I will use Altium, and in that case I want to use Altium because this is such a large-scale project, and I want the mechanical and the electrical integration to be basically flawless. Because if I order boards or whatever, they don't fit in the end. There is no way back. This is a damage of 10,000 K or whatever. Yeah, you don't do any. Yeah, that's all right. I mean, nobody does projects of this scale, but it will be a great showcase for Altium basically, to have like a reference, and that's the only intention, is to see what is possible and what is fun, to like basically support makers like me to make the those those mad projects or whatever. Anyways, let's not talk about too much about this business part, because that I want the fun part. And we wanted to download. Is this? Yes. No, wait. Where's my CH? 32H417 DS. Here there is the environment. Yes, certainly I want, especially with the bus lines, I want to check reflections, impedance, stuff like that. It has to work. Yes, it has to work. I hope that those tools will. It's only, yeah, it's 24 megabytes. Done. Okay. Let's see. Let me put it here. Oh, that's a big. Why is it so slow? I should have used 7-zip. downloads. That's the Bluetooth, I think. The Bluetooth parts here. Is it human interface? Yeah. Okay, weird. 957 to 8. That's the Bluetooth stuff. Okay, USB, MCU, RISC-V. Is this Bluetooth? RISC-V, MCU sock. Okay, here we go. Yeah, I think I will try for the third level MCUs. I will try to do a generic design that is pin compatible with more than one MCUs. And I hope they are pin compatible across several MCUs, like with the QFN20 pin version. I don't know if they're all the same size. QFN20 pin might be all the same size, and I hope that several MCUs will fit the footprint. So actually, same design might work for different things. Oh, look at that! The 470 isn't here yet in this list. Strange. 317 is though. Okay. Example. Pips, let's oh, okay. What do we have here? ADC application can QSBI SD MMCT timer USART USB high speed device. UDisk simulates CDC. What is high D? Okay, let's take a look. I just need a USB cable here. Do I have one? Yes, here. Project template. Okay, upgrade it. And I think I got the link E. The link E might be that I got from WCH, might be updated already for the latest version. I need new version. I need to close the other ones. Other instances, where? No. Huh? I can't see other instances open anymore. It's still there somehow. Okay, let me find it. Why is it so? My system is. What is going on? I just changed the order of. Oh, I have DaVinci Resolve running. Oh, okay, let me close that. That takes like 32 gigabytes of RAM or 64 gigabytes of RAM. That's the Moon River installer. Okay, bye bye. We'll start the design next time. Maybe that's the Visual Studio Code that is detecting. Shoot. Oh no. There is no other instance running. Okay, F this. We just started without stupid. Okay, here, simulate. Let me connect the Linky. But I really need to find out which pins I need to connect it to. Huh? Oh, camera is down. Yeah. Key ground. V-bus. That could be a debugging pin. This is ground, so this will be. I have no clue if it's the debugging. I would need to check the data sheet. I'll just test it. Interesting, there are like two projects. One is for the first core and the other one is for the second core. The file has to be merged. Wait, what? The file simulate to be. What is the error? I can't see. After building does not exist or is invalid. Oh, I might need to update it for that. Damn it. Ah. If I restart, okay. So chat will stop. What? Oh. What kind of workspace is that? I don't care. Micro Pico, yeah, I don't need it. Code. Okay. Let me start again and see if we can. Otherwise, I need to do it offline, and then. No update prompt. Check updates. Oh, I'm downloading it again. There is no other instance. Damn it. Where? I don't see another instance. Oh, I'm not pursuing this too much on the table right now. I will send it to TL, maybe one of the boards. At some point I might try to debug it again. But right now I have basically, I'm a little bit, I don't know, upset about the MCU at all, because it's so difficult to work with, it seems. What is this? Visual Studio Code. There are like a gazillion instances of Visual Studio Code. Okay, let's try again. No, still. Oh, okay. How do I download? No, you didn't miss it. Wait. Where did the update download? No. Oh, is this annoying? Next year? Yes, maybe. Where is it downloading to? Wait, you know what? Offline update. Offline update. Browse location. Okay. So basically downloads and then. Oh, that's when you have downloaded the stuff. Ah, damn it. I can't get it try again. I need to restart my system, it seems. Yes, Christian, thank you very much. Amazing, amazing. Twitch already so long, YouTube even longer. Okay, I have the I'm downloading the version from the zip, the offline one. If the compilation, like the build step that combines the images, doesn't work, I need probably assistance from Patrick. So that will be the end of the stream if that doesn't work. And this won't work. Oh! Now it works. Yes. Strange. Okay. Uninstalling, okay. Yeah, this is doing a lot. This is the major design here. Nice. Booster was good, but not enough. We should have opened the other can. While this is installing, I can check for the datasheet. Prehistoric, yeah. Wait. Schematic, okay. Oh wait, 417. I think this is the data sheet, so we can see the pins here. Oh, look at that. PB8 and 9. Yes, I'm right. I had it right in the first place. Okay, clock is 8. Oh wow, by coincidence I connected it correctly. That's cool. All right. I don't need to run it now because I will open again. Wait. Okay, let's open the project. There you go. Let's hope now it works. Yeah, I think this is the second USB peripheral, is it? Yes, that's the second USB. That's the first one is I think OTG. No, wait. This is USB 2. Is this? Yes, OTG. These are the regular USB. This is the host pins probably. You can share them with like host because after you can always switch on the debugging interface if you want to turn it on. I don't know why this decision, but it's not shared with the first USB. That's why it's probably OTG ID and V bus. So that's the USB 3 pins. I have no clue. So will be, we have D, F, PF, PC, PE. What is MD? What is this? MD, IRN. Ethernet. Ah, okay. Interesting. Okay, so Ethernet have dedicated pins. That's cool. That's Ethernet then. Yeah, I'm curious if I even have my 64 pins here. Ah, C, D, B, E, P, B, C, A. Bitbank 100 base TX? No. Was it on YouTube? Who did it? Build finished. Ah, build finish. Oh. Okay, Linky is upgrading. Now I'm curious. Fail to erase code. Tools. Ah, PIOs then. Okay. It's not communicating. Did I do something wrong? Clock is 8. IU is 9. We can't connect right now, so let me check again. Clock B8, B9. Okay, let's do different tool. Let's try the MCU series. I don't think this will. Oh yeah, it has it here. USB port. Okay, let's try. Okay, pressing the user button doesn't work. I also don't see any power here. No LEDs light turn on. Oh wait, is there a switch somewhere that I missed? Okay, let me add some power lines to the V3. This will probably be not good enough. Like, now it turns on. It seems like I missed something. There probably is a jumper that I need to connect. There's like some unpopulated stuff here, so I'm not sure about that. There is a regulator here, but I got it now. Okay, let's program it now. Here we go. Download finished. Okay. What does it actually do? Because we have 2 cores. Printf, wake up. Oh, that's human interface device. Yeah. Okay, and this one here. Okay. Let's see. multifunction device. No. What did we open? Ah, no. Link. I thought we made simulate. Wait, is this simulated or what did I do? Oh, CDC and human interface device. Okay, interesting. It wouldn't show here. Connect. Yeah, I don't see it here. Okay, let me try a different example then. Simulate CDC. Let's open this one. But we can compile. Yeah, compile everything. Dude. Merge bin. Okay, download it. Okay, now it's oh, almost dropped it. Can't see the CDC. Download finish. Okay, what is this? What is UVC DVP? That's USB super speed? No. I'm actually not familiar what steps I need to be able to work with that. Let me close that again. What is this project? UVC DVP. UVC DVP. What is that? Oh, thermal camera video module. Oh, that's like an interface for the thermal camera or what? Okay. Let me check that. Fast take release on semaphore. System clock update. And what does this one do? Or hardware. Enter stop mode. VDD12. Interesting. Okay. Ah, 125. How can it achieve like is this like a double data rate and then you have um, then you have the additional 25 megahertz for the additional bits that you need, like because it's 10 bit instead of 8 or something? What does that mean? I'm not familiar with Ethernet. Maybe you clarify what that means. Ah, okay. Oh, that's built old projects. Okay. And this is oh. Ah, okay. So what is CH32 device? Okay, we can use this button to build all. I will use. Did it build? Or was the. Oh, that's unused. Okay, no worries. Merge bin. Oh, wait a second. Okay, I need to get more info how to use the examples because I'm really not sure. This is not. That's divide. Show me that. Overclock 960 megahertz PLL, and then division. What is the division? Sys clock. What is sys clock? Oh, 250. Okay, I see that. Okay. That's substantial. Huh? Mm. Yeah, I know, I know. I just wanted to participate a little bit. I don't see it actually turning on, like it adding PCI Express. Okay. No. I have no clue how to configure it to. It seems that we are able to communicate, upload something, but I don't see the project running though. So this is system init uart printf. It might be that it's halts somewhere. Should we debug it? Maybe we can debug it. Okay, new window in debug mode. Let's see what it does. Ooh, okay. Some serious business here. Let me do system clock. Okay, F10. Wake up. Oh, interesting. Okay, this one is running. But where's the other one? This is the 5S. How about, oh yeah, this is the next core. Okay, this is interesting. Both cores, you have like an individual window for each core. Enter stop mode. Power regulator on. Stop entry. Okay. Hey, Hack Now team. Okay, where are we here? Oh, this one is... This white one is in endless loop. Run core. Okay, where's this defined? Okay, it should run both cores. But why is the other one halted? This one entered stop mode here. I'm testing a new board, the CH32H417. Now I heard a new device appearing. Where's the device manager? Wait, maybe we see it here. Serial USB. What? Okay, somehow now it's out of the halt mode or what? I don't know what I have to do. No, I don't see it listed here. Huh? It has like different code for like different projects for each core. It's weird. So I saw count 21 communication port. Okay, let me check. 21. Where's 21? Oh, here. It's showing up 47. Oh, it's here. It's here. Okay, okay. What does it do? It doesn't do anything. It just, oh, okay. It runs now. Can I reset it? Okay, it's gone. Now it's here. 5 gigabits. Okay. Okay, let's try simulate CDC over super speed. That was fast speed, super speed. Oh yeah, no, that we don't have UVC. What is CH372 device? What is that? Yes. High speed. I think we have only high speed UDisk, because I wanted to see this thing running. UDisk. So weird. Oh, because we are debugging right now. Okay. Let me stop the debugger here. Boop. Oh no. Where is our UDisk? Okay, here we go. Merge. Now download. I want to see. Okay, let me check if I can. Dual core. Okay. Didn't work. Okay, it's probably still debugging somewhere. Simulate CDC. This one. Let me close that one. That one. That one. That one. I don't know how to. I might still have the issues with the power, but okay, let me check. No. Okay, let's reset it completely. Linky not found. Ah. How? Okay, it was able to use Linky here. Now, let's start debugging. Request is cancelled. What if I debug it here? Oh, I have to debug on the first core project. No, still not. Okay. Okay, peeps. It was working somewhat. I think that's enough for today. We will try next week. Thank you for joining. Sorry, Hack Now team. You're a little bit late to the fun. We repaired my car today and then started have tried this here. You're welcome. Thank you very much for joining. Yeah, looking forward to next week. Ultra cluster will be coming. You saw the mock-up. The madness. I think bit banging is better than SPI because we need like a lot of communication, and I need to Wednesday, as always. No exceptions this week, this upcoming week. Bye bye everyone. See you. Have a good night.